Once again, welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And we are now getting to the deeper end of the topic, graphs 9. And we have gone through or understood the slide that was before this one. And we have just studied what is the rate of change. And in this question, or in this example 10, we are going to see a real life rate of change, and the explanation of this question will give us more information about how we deal with such questions. And we are told that the depth of water in Y meters in a tide or harbor entrance, T hours after midday, and I would want you to underline after midday. This is something that we have to be keen about or with. The depth of water in Y meters in a tide or harbor entrance, T hours after midday, is given by the formula Y is equals to 4 plus 3t minus t squared, where t is between 0 and 4, both limits included. Now, I think before we do anything else, it is important to have an idea of what we are dealing with. Because this is a curve, we are going to have a quadratic graph here. So it is important to kind of have an idea of the graph we are going to deal with. And therefore, though this one is not required, but I want to start from there. If we may want to have the graph, plot or sketch this graph, I would have t here versus y. And because we have 0 inclusive, when t is 0, and when t is 0 is now 13 hours, and no, not 13 hours, but 12 midday. When t is 0, it is at 12 midday. When t is 0, then we have 4 plus 0 minus 0. We have the height being 4 meters. When t is 1 hour after, then we have 4 plus 3, because t is 1, which is 7. 7 minus 1, because 1 squared is 1, then we have 6. When t is 2 hours after midday, that is at 14 hours, we have 4 plus 6, because t is 2. That is 4 plus 6, 10. 10 minus 2 squared, which is 4. Again, we get a 6. When t is 3, we have 4 plus 9, that is 13. 13 minus 3 squared, which is 9. 13 minus 9 is 4. And when t is finally 4, we have 4 plus 12, which is 16. 16 minus 4 squared, which is also 16. Then we have the height of the harbor being 0. Yeah, we may want now to come up with something or a sketch, if that is y, if we could have y there, and we could have now the t here, if we could have the t's there, whereby t is time in hours after midday, after the first hour, the second hour, the third hour, and the fourth hour. This is 1, 2, 3, 4. This is 1, 2, 3, 4. And this is t, time in hours. Of course, after midday, we have such kind of an axis. And the highest y we can see is a 6. So we could have our 1, 2, 3, 4, 5, 6. 3, 2, 1. This is y, of course, in meters. Now, if we now have the xy Cartesian plane, it's just a rough graph of what is happening. When t is 0, as you can see, y is supposed to be 4 there. When t is 1, y is supposed to be 6 there. When t is 2, y is another 6 there. When t is 3, y is 4 roughly there. And when t is 4, y is 0, as you can see in the graph or in the table. So very smooth curve, freehand. This is what we are going to kind of have, and there we are. That is the curve we are dealing with. And of course, we having identified a curve, then we straight go to questions, because we are told, or we are asked to find the rate of change of the depth of sea water in meters per hour at 13 hours to start with. But the keyword is the rate of change of depth of sea water in meters per hour. This is where we are. Meters per hour, that means the rate of change of the depth with time. That means the depth is y and time is t. According to calculus or differentiations, so far what we have understood, we have to do with, we have to calculate now dy dt, the change of depth with respect to time, which is, as you can see, this is 4 is a constant, is going to die. This is 3t raised to power 1, so the differential of that is just t, and this is minus t squared, whereby it's minus 2t raised to power 1, and that is just the differential. Now we need to understand at 13 hours, t is in this case 1 hour after midday. So at 13 hours, t is 1. So what is the rate of change at 13 hours? We just substitute t with 1 in this particular differential. Now this is going to be 3 minus 2 times 1, which is 3 minus 2, which is just 1. This is 1 meter per hour. 1 meter per hour. And since it is indicating positive, therefore we are having a positive gradient, which the depth is increasing. The depth is increasing. We can simply say the depth of the harbor is increasing. That is it. What about at 15 hours? So at 15 hours, t is equals to how many hours after midday? These are 3 hours. So t is 3, because from 12 you go to 13, 14, and to 15, 3 hours. Again, what is the rate of change of depth? We substitute in the gradient, which is 3 minus 2, 3, which is in this case 3 minus 6 is minus 3 meters per hour. Again, you can see now the gradient is negative. That means the depth of the harbor is decreasing. This is decreasing. And as you can see now, we have at 14, at 14:30, at 14:30 hours. How many hours after midday? In this case, t is equals to 2.5, because from 12 to 14:30 is 2 hours and a half, 2.5. Again, substituting in the gradient function, which is 3 minus 2, 2.5. This is 3 minus 5. This is 3 minus 5. And we are getting 3 minus 5 is minus 2 meters per hour. Again, decreasing, easily decreasing. You can see the depth of the water in the harbor is decreasing. Now we have answered part A of the question. 1 meter per hour is at 13 hours, and negative 3 meters per hour at 15 hours, and negative 2 meters per hour at 14 and a half hours. That is that. But before we can actually, in fact, go to question part B of the question, when t is equals to 1 at this particular point, then this is the point we are talking about. The tangent of the curve at that point can look that way, and you can see the gradient is already positive, and it is indicated here. That means, or that shows we are right. At 3, after, when t is equals to 3, here we are expected to have a negative gradient, and here we are. If that curve, we can have the gradient, the tangent passing there, and as you can see, when the gradient is now touching the curve at only one point, that is the tangent. When the tangent is touching the curve at that point, you can see the gradient is negative, and of course it is explained here. Let us then go to part B of the question. Part B of the question, which is saying, find the rate of change of the depth of seawater in meters per hour when the harbor entrance is dry. I would want everybody to note that when the harbor entrance is dry, there is 0 meters. That means y is equals to 0. And because we know y was equals to, or still equals to 4 plus 3t minus t squared, it is important to know that this one is, we can talk about minus t squared plus 3t plus 4 is equals to 0. If you ask me, I would take everything across this side and 0 comes this side. We are going to have t squared minus 3t minus 4 is going to be equals to 0. Then we can easily factorize this quadratic equation. And if we go by the BAC approach, and we know what this is, our B is minus 3, our AC is minus 4. Which two numbers that we add, they give us a minus 3, and we multiply, they give us a minus 4. This is easily minus 4 plus 1, and minus 4 times 1. So we can easily now substitute the middle term, and we are going to have t squared plus t minus 4t minus 4 is equals to 0. Factorize t outside. In the bracket we have t plus 1 minus 4 t again plus 1 is equals to 0. In this case we have two brackets, t plus 1 and t minus 4 giving us 0. It is either t plus 1 is equals to 0, and if this is true, t is equals to negative 1, or t minus 4 is equals to 0, and if this is the case, then t is equals to 4. It is very, very true, because even with our graph, or from our graph, we can see when t is 4, then the height of the harbor is 0. We would have just identified from the graph, but I felt that we should be able to calculate the value of t when the harbor is dry, or when y is 0. You can see t is 4 in such a case. Now that we have found our t is 4, we have to ignore t being equals to negative 1. We have to ignore that one, because it is outside the bracket. It is outside the domain. The value of t given or allowed. We are allowed when t is between 0 and 4, both extreme or both limits inclusive, but negative 1 is below 0, and therefore this one is not going to be used. So we can easily ignore that, for the reason that I've explained. Now, find the rate of change of the depth of the seawater in meters per hour when the harbor entrance is dry. Now what do? We just have to substitute t in the gradient function, or the dy dx, because they are talking about the rate of change, meaning that dy dt is going to be 3 minus 2, 4. That is 3 minus 8, which is negative 5 meters per hour. That is the rate of change 4 hours after midday. And 4 hours after midday is actually at 16 hours. And that is the solution to that question. Of course, you can see even the depth at that particular point is still decreasing. It's still decreasing. Well, thank you for following me, and that is the end of that question. Let us meet in the next video. You can see where we started, how we solved the question step by step until we got where we are to at this particular point. Follow it, and you can follow the video, pause, and of course ponder, and as you reason together and along with the video. Let us meet in the next video. Thank you.